This is where we left off in our last video. So we looked at the theory behind using integration to find area. Alright? So here it is the integral from a to b of f of x dx, where the area to be found is between the lines x equal a, x equal b, the x-axis, which is the line y equals 0, and y equal f of x, whatever function that is. Now, let's look at an example. Suppose you're asked to find the area bounded by the curve. And let us draw our x and y axis first. This is our y axis, our x axis. The area bounded by the curve, say, I'm having a little challenge here with my technology. Let me deal with that. Y equals 0, which is the x-axis, right? The boundaries are the x-axis, x equal 1, x equal 7, and y equal, let's say, 5. Suppose that is the case. Let's just do a little sketch of it first to see what it would look like. X equal 1. Let's put some numbers on the graph first. You have 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. The lines are x equal 1, that's x equal 1, x equals 7, that's that line, y equals 5. Now we put the numbers here, 1, 2, 3, 4, 5, 6, and so on. So the line y equals 5 would be here. And the x-axis, which is the line y equals 0, which is, of course, this line. So the area that we're calculating is this region, this area here that is shaded, all right? Now, we can use two methods to find this area. We don't necessarily have to use integration, okay? So, first, we can just multiply the width by the height of the rectangle to get the area. If we do that, then the area is equal to, how wide is the rectangle? 7 minus 1. So that's 7 minus 1, that's the width, multiplied by the height, 5 minus 0, which is just 5. So it's 6 times 5, which is 30 square units. So we have an area of 30 square units. But anyway, suppose we now try integration. Let's see what we have. It's integral from a to b of f of x dx. So our area is equal to the integral from a to b of f of x dx. Alright? Now, this means the integral from a, in this case, a would be 1, b would be 7. So it's from 1 to 7 of f of x. F of x is the same as y. Right? This could be written as the integral from a to b of y dx, right? But in this case, our y is 5. So it's the integral from 1 to 7 of 5 dx. So we're going to see how that one goes. Here, what we'll do is say, when you integrate 5, you get 5x. Because remember, 5 is going to be 5 times 1, which is the same as 5 times x to the 0. So when you integrate, what you do is add 1 to the power of x, which is x plus 1 divided by the new power x plus 1. 0 plus 1. You add 1 to the power, so you have x to the 0 plus 1 over 0 plus 1. So it's just 5x to the 1 over 1, which is 5x. Just as a reminder, right? So here, this is 5x. Now, how you write the integral is you use square brackets, remember, use square brackets, and the lower boundary on the lower right, and the upper boundary on the upper right. Okay? So, here, what you're going to have is you substitute 7 for x, so it's 5 times 7 minus, so you substitute the upper boundary minus 5 times the lower boundary, 1. So it's 35 minus 5, which is 30 square units. Same 30 that you got earlier, all right? So here, what you do, you subtract these units. So when you say the integral from 1 to 7 is like you're saying you have going up to 7, so you calculate the entire area up to 7 minus the integral involving 1, the lower boundary. So it's everything minus this area here to give you the area that you want. So you can consider it that way. The upper boundary, the calculation minus, and then the lower boundary. So we get 30 square units in this case.